Okay, so I pulled up 6 different types of factoring problems. So it kind of hits one of each type. So again, just to go through some of the factorings, when I have a trinomial, I want to use what's called the diamond method. It's kind of beneficial to help you out. What you're going to do is you're going to multiply the first and the last term. Okay, so this is a 1. 1 times 12 is being 12. The middle term is the bottom. That's your b value. So that'll go on the bottom of it. And your goal is to figure out, well, what times what gets me 12, but if I add them, will get me a -7. So in this case, it would be a -3 times a -4 is going to get me positive 12. -3 plus -4 gets me a -7. Now, as long as this is a 1, you can do a shortcut. The shortcut is you split your variable. So x squared is split to x and x. And then those two factors you just came up with, -3 and -4, are the factors inside your parentheses. Okay, and that would be your factored term for number 1. For number 2, first thing you should do, I see a leading coefficient of 2. I'm going to see, can I divide them all? Do I have a GCF? In this case, I do. I can divide all of these by 2. They're all even numbers. So when I do that, 2 is going to come out front. And then again, I just divide each of these individually. So v squared, 28 divided by 2 is 14. And then 90 divided by 2 is 45. Then I'm going to do the same thing I just did in the first question, but just on the inside grouping. That 2 is just going to drop every time I factor. So again, I'm going to go back to the diamond method. I'm going to multiply first is still a 1 times 45 gets me 45. Middle term is 14. So factors of 45 that would add to 14 is going to be 9 and 5. 9 times 5 is 45. 9 plus 5 is 14. So the GCF 2 drops down. And then again, this was a 1 here. So I can do that shortcut. Split it. One set with a v in each. And then again, my factors that I found, the positive 9 and the positive 5, get placed in my back terms there. Okay. For number 3, 3a squared plus 7a, only 2 terms. So really your only options are GCF or perfect squares. 3 and 7 are definitely not perfect squares, but looking at them, I do see an a in each of them. So that would be my GCF here. 3 and 7 have nothing in common other than the letter A. So I can take the A out. When I do that, I still have the 3. I didn't touch my numbers. A squared, I took 1 away, so I'm still left with 1. 7a, again, I still have the 7, but I took the A from the A, so that completely went away. And this would be just a simple GCF problem. Okay. So now number 4, this one, there's no GCF, 6, 11, 30. They have nothing in common. They all don't have a P involved, so I can't take a GCF out. So I'm going to have to do the diamond method, but this one's going to take a little bit more work involved. Okay, I'm still going to multiply the first and the last. This time, though, I actually have a first term. I have a 6. So 6 times a -30 is a -180. The middle term stays the middle term, so -11. So I'm going to have to play around with this. I want to see, well, what factors of -180 would get me an 11 in when you add them. So when you do that, again, you can start thinking of pairs. You could start doing, 180 times 1. Obviously, that's going to get you 180, but it's not going to get me to 11. I could do 2 times 90, still not going to get me 11. And you can keep working your way through it until you find that it is a -20 and a +9, right? -20 times 9 is a -180. -20 plus 9 is a -11. Okay, so now in this case, Because this is not a 1, I got to do some extra work. I have to bring grouping involved. So you drop the first term and the last term. So the 6p squared, the negative 30, and then the factors that I found get put in the middle. So I split this negative 11 into those two. From here, I'm going to group it. First two, last two. Okay, so looking at the first two, 6p squared and a negative 20p, they definitely both have a p. And 6 and 20 are both divisible by 2. So I'm going to take a 2p out. When I do that, 6 divided by 2 is 3. P squared, take one of the p's away, is just p. Negative 20 divided by 2 is a negative 10, and the p went away. So now I have an idea, because the goal is to get these to have the same parentheses. I want them to factor to the same thing. So my goal is to get another 3p minus 10 in parentheses. When I look at the second grouping, a 9p minus 30, they're both divisible by 3. And you take the sign of the first number. So it was a positive 9, I'm taking a positive 3 out. When I do that, 9 divided by 3 is 3p on a good start. Negative 30 divided by 3, negative 10. There we go. So again, this was our goal that we wanted to have happen. Because now to finish my factoring, we're going to take that 3p minus 10 that they both share out, and then their GCFs that we took get to go together. They get to be their own grouping. So this is going to factor to 3p minus 10 and 2p plus 3. Okay, so that's when we have a leading coefficient. You have to go through that longer step. When it's just 1, like the one above it, the first two, we can do a shortcut. Okay, and our last two questions, 4a squared minus 9. Again, like number 3, I said the only way to factor a binomial, two terms, is if there's a GCF, which there's not. 4 and 9 have nothing in common, and they both don't share a letter. Or are they perfect squares? And in this case, they are. A 4a squared, I can split evenly to a 2a and a 2a. And that negative 9 on the end, I can split to a 3 and a negative 3. Same number, just opposite signs to get me the negative. So when I can do that, as long as these are all identical, they're perfect squares, I can group one of each, 2a and the positive 3 and 2a and a minus 3. Okay, we call that a difference of two squares. Okay. And the last one, number 6, is similar to number 4. There's nothing in common. There's no GCF. So I'm going to jump to using my diamond method here. Okay, 16 times 1, I'm going to have a 16 on top. I have a negative 8 on the bottom as my middle term. So factors of a positive 16 that add to a negative 8 are a negative 4 and a negative 4. So again, I'm going to do like I did up here. Drop the first term, drop the last term, stick those factors in the middle. That's what we're splitting our middle term into. And then again, we're going to go into grouping. So first two, last two. First two, 16n squared minus 4n. Well, they're both divisible by 4, and they both have an n. So that's the GCF I'm taking out of those two groupings. 16 divided by 4 is 4. N squared, taken n away, is just n. Negative 4 divided by a positive 4 is a negative 1. And again, that n went away there. And again, remember, this is our goal now. My goal is to get a 4n minus 1 in the second grouping. Now, the second grouping have nothing in common. 4n, negative 4n, and a positive 1. But they're the wrong signs. I need a positive 4n and a negative 1. You always have to take something out of the last grouping. It could simply be a 1, but you have to take it out. In this case, I'm going to take out a negative 1. The negative 1 is going to change my signs. So now I can have identical groupings here. So that way, when I finish my factoring, the 4n minus 1 that they shared goes out front. And then their GCFs, which happen to be another 4n minus 1, gets put in the back. You could leave it like this, or just for your own knowledge, you may also see it like this. 4n minus 1 squared. Okay, that might be another way you see it written out. Because they are duplicate, you do have 2 of those. Okay, so hopefully this helps you out with some of your factoring.